All right. So our goal today is to figure out patterns and relationships between two sets of variables. In this case, I set up x and y as our variables. Our goal is to figure out how does x become y. Well, in this case, we have 2 as our first x and y, 6 is our first y. So we have to think about how do we get from 2 to 6? Well, I know that there's two very obvious ways that I can see that 2 can become a 6. I know that I can do 2 plus 4 equals 6, and I also know that I can write 2 times 3 equals 6. The pattern that you're going to look for is the one that's going to work for every single x to y. So whenever x is a different number, the y, whichever pattern you choose, has to match for what y is going to be. Well, I know 2 plus 4 does make 6, and I know 2 times 3 also makes 6. So these patterns both work for 2 turning into a 6. Now, if I move on to the next set, where I have a 4 and a 12, I notice that the 4 plus 4 is only equal to 8, while the 4 times 3 is equal to 12. So I know right now, just from my second set of numbers, that the plus 4 does not work. So plus 4 cannot be the pattern that we're looking for here. So in this case, we know the pattern is times 3. Now, to generalize a rule for this, we have to figure out how to write it in terms of x and y. So I know that whenever I do x times 3, that's going to give me my new y. So if I wanted to plug in a new number, let's say that we wanted to find 12. When x is 12, what is y? You're not going to sit there and go 2, 4, 6, 8, 10, 12 because you can skip ahead. You're not going to go 6, 12, 18, 24. We can skip ahead. We can plug in our new x value into our formula to figure out what our new answer is going to be. And it's going to be 12 times 3 equals 36. So when x is 12, y is 36. Let's go ahead and try that with another example. Given 2, 4, 6, 8 as our given values of x, and we have 6, 8, 10, 12 as our values for y. We can try to generalize a pattern going on here. To get from 2 to 6, I know I can do 2 times 3 equals 6. I can also do 2 plus 4 equals 6. And I can generally write down anything I can think of, but these are the first two that come to mind when I'm thinking about patterns. Well, 2 times 3 is 6, we proved that. 2 plus 4 is 6, we proved that. So both patterns work. What about 4? How does 4 become an 8? Well, 4 times 3 is 12, but 4 plus 4 is 8. So we notice that we chose a plus 3 pattern and a plus 4 pattern. A times 3 pattern and a plus 4 pattern. The times 3 pattern does not work for the given values of x and y, but it does work for the plus 4 pattern. So we know that the plus 4 pattern works. If we test it out with the other cases, 6 plus 4 equals 10. We did get a 6 and 10 pair. That works. We did get an 8 plus 4 equals 12, and this plus 4 also works for the 8 turning into the 12. So the rule here that we can generalize is x plus 4 is equal to y. And if we plug in any value of x, we should be able to get y. So let's say I wanted to find what is y when x is 28. We could just plug in x, which is 28, plus 4 equals 32.